So now we're going to discuss example 27.3 in the chapter text. The differential equation that we're going to solve using the method of finite differences is the following. The second derivative of t with respect to x plus h prime t a minus t equals 0. We're going to describe the physical system, but it's not really necessary to understand the physical system in order to solve the problem, although as engineers, we do prefer to know what is going on physically. H prime is a type of heat transfer coefficient. I'm actually not going to describe exactly how it's determined, except to say that it's a constant. It's a constant that involves both conduction and convection, and so it's kind of beyond the scope of this class. And TA is actually the ambient temperature, and that, again, is a constant. So let me explain what we actually mean by this. So what we're actually doing is we're calculating the temperature profile as a function of x in a rod that is in touch with two walls. So you have a wall on the left and a wall on the right. And these walls are at different temperatures. This is x equals 10. And the assumption being made here is that the rod is at the temperature of the wall where it touches the wall. So in other words, T at x equals 0 is going to be 40, and T at x equals 10 is going to be 200. So that gives us two boundary conditions. And what's actually happening physically is probably worth mentioning, although you don't really need to understand it. You have a high temperature wall at 200 degrees. You have a low temperature wall at 40 degrees. So heat is going to be conducted through the rod, and the rod, especially when it's in contact with the high temperature wall, is going to be hot. And if there is air present, what we say is we have an ambient temperature of 20 degrees C. Then what's going to happen is where the wall is hot, it's actually going to transfer energy or transfer heat to the air, which is at a lower temperature. And so this heat transfer coefficient considers not only the thermal conductivity of the rod itself, in other words, heat transfer through the metal rod, but it also considers the exchange of heat to the air. Again, you don't actually have to know that right now, although you will study this in your transport class. So what we're going to do is we are going to use the method of finite differences. So we're going to approximate the second derivative using the following centered finite difference approximation. And we're going to define the following grid. X0 is 0, X5 is equal to 10. And for the sort of handwritten portion of this, I'm going to use a step size of 2. So this is 4, 6, 8, and 10. We're going to have a T0, T1, T2, T3, T4, T5. And we actually know the temperatures at the beginning and end. So T0 is 40 and T5 is 200. And what we have to solve for in this case is T goes from I equals 1 to I equals n minus 1, where n is the number of steps. So the next video is going to actually talk about how to set up the matrix. We're going to illustrate it for the step size of 2, and then subsequently we'll make another video. We'll go to MATLAB and we'll talk about how to write a script to actually calculate the solution.